Hello and welcome to the Cyber One YouTube channel. My name is Ray, and in this video we're going to do a repair. Okay, so this is part of or one of the circuit boards out of a water flow meter used in industrial applications, manufactured by Siemens. I've had two of these fail. This is actually the second one, and I don't really know why it failed, but we do know that the two have failed in the same place. So after a successful repair of the first one, I thought I'll show how I went about doing the repair on this one. So the water meter in question consists of the water flow sensor, which is plumbed in and has an attachment that you can either put a cap on and then wire it remotely to the electronics component, or you can plug the electronics component on the top. The electronics component plugs into this board, and this board mounts inside the base under normal local operation, which is how we're using it in the flour mill. For those of you who are not aware, we do add a significant amount of water to wheat prior to milling, and this is how we monitor the rate of flow of that wheat and other instrumentation to monitor the rate of flow of the wheat and the moisture content of that wheat, so we know how much we want to add. Now in the first one, it's just popped the breakers, and it was a significant pop of the breakers. It took out the 4 amp breaker that feeds this unit. This unit doesn't draw much power, it's less than an amp. It also tripped the 8 amp breaker that feeds the main power in that control system for adding the water, and the 10 amp breaker that feeds all of that back at the switchboard. So with the 3 breakers all going at the same time, we knew we had a fairly significant failure. When I repaired that board, that solved that issue, but because we didn't know what the failure was or what the cause of the failure was, we actually got a whole new unit and installed it. So 8 months later, and it failed in exactly the same way. So this is actually the board out of the second one. I repaired the first one and I actually reinstalled it, and it appears to be working quite well. Now this board has no electronics on it. It is simply a connector board, designed to allow us to bring our wires in and connect to the various points, and then the electronics literally plugs in on top onto these 2 connectors. Now because bases can vary a little bit from unit to unit, and this is a very accurate meter, they actually have a module that plugs in here with the configuration data for the module. So I didn't bring the electronics home with me to do this recording and testing because I don't have a spare base. Now the failure appears to have occurred just in here, and you can see there's some black marks. I'll put this under the microscope. How about I start it recording even? Okay, so you can see just in here we've got some arcing around here. Now this board has a ground plane on the top here. There's also a ground plane on the bottom. So for these connections to make it through to here, there's actually an embedded layer of copper. Now, if I turn on this multimeter, I won't say multimeter, this is an insulation resistance tester, commonly referred to as a Mega in Australia. This one is the one I normally use at work. It is a digital one, and I've set this at 250 volts. That's the supply voltage. Now, when we're installing these things, we do have to test them at 500 volts. So if I turn this on, we got 252 volts at the probe tips. And if I get it in the right spot, it's hard to see it. There is some arcing there. I measure between the earth terminal here and here, we get a dead short. If I measure to the neutral, 200 volts, we get 252 volts, we get 200 megohms. And if I measure to here, we get 0.16 thereabouts megohms. Now the limit here in Australia is 2 megohms, but as a matter of practice we would like to go far higher than that if we can. If I actually turn the voltage up on this, you can see the sparks better on the probes. And if I go between here and the active terminal, you can actually see it sparking. So we've definitely got a short to the ground plane. There is no short to the neutral, which is right next to it, so it is purely the ground plane. And that's exactly what went wrong with the other one. So what I'm going to do is desolder these 3 terminals, remove that connector, and we're going to clean up the damage that occurred underneath there where it shorted. Again, I don't know why it's done this. We've got 2 of these units in service and the other unit has never failed. Right, let's get to this. Now most of these boards are done with the lead-free solder. They run a lead-free solder is a higher temperature solder, and it is a lot harder to desolder with. So I'm just going to dilute it a little bit with some standard leaded solder, which does make a difference. This last terminal on the ground plane, the earth wire, is going to be the hardest one to remove. That's because it's got 2 ground planes. Those ground planes will suck the heat away almost as fast as I can get it into it. Now I normally run my soldering iron here at 330 degrees C. For this earth pin, I am going to run it a little bit on the higher side because it is so much harder to heat it up with the ground planes. So I've turned it up to 360 degrees C. I think I might have to get more solder onto that so I can conduct the heat. It's better it's melted in. It's running cold. Even at the higher temperature setting. Got it. Okay, so I've cleared the holes out. Okay, so let's have a look at the connector itself. As we can see, the neutral wire, which was the middle one here, was not affected at all by this shorting. There is some burning along here, so we might scrape that off with a small knife just to make sure it doesn't short anymore. This is the one that had the arcing on it. On the bottom side of the board, you can see here I've cleared out the 3 holes. Doesn't appear to be any damage to the pads at all, which is good. On the other side, you can see the extent of the damage there. So I'm going to grab a cotton stick and give that a clean up with some isopropyl alcohol. Okay, that'll do for that cleanup. Now, I noticed when I did the last one, after I did the cleanup, after removing the connector, the insulation resistance came back up, and I just want to see if it did on this as well. So back onto the ground plane. And that's brought it back up. Let's try it at a higher voltage. You know it arced over very well at 1000 volts, and it's now passing at 1000 volts. It's greater than 500 megohms, so it is passing at the moment, but it has had a carbon track through there, and that carbon track, when we look at it, could break down and cause an issue again. With 240 volts there, I really don't want to do that. So let's get a knife, sharp blade of some sort, and just clean away all that evidence of the carbon tracking. Pretty good. Don't want to dig down too deep because I know there are sub layers here. So I'm just going to hit that again with isopropyl alcohol. Interesting where it actually arced across. In the last one, it was more down towards the middle of the L1 here. This one has come across this way more. Now I don't know why it's done this. That gap between there and there is plenty big enough. It should never have done that. So it really is a mystery. You've got the same voltage between this point and this point, and this point and this point. So I really don't know why it didn't arc that way, and it did arc this way. And it's probably something that we'll never find out. Okay, so that appears to have dried now. So I want to re-insulate this. I want to make sure that this doesn't happen again. So in order to overcome that, I've stolen some of my wife's nail polish. This is pink, so it should stand out nicely on this board. We don't want to cover the pad there, but we do want to make sure we fill in everywhere where that arc occurred. And I'm actually going to do multiple layers here. Now this nail polish is an acetone based nail polish. Oh, I'm waiting for that to dry. Let's clean this up a little bit. So remember, this had a little bit of burning around the top edge. Just going to scrape that away. It looks a bit better. Down another coat. It's a nice thick coating. It's not going to have any insulation resistance breakdown through that. As soon as that is dried, we can solder it all back together. Okay, so let's solder this back on. So I'll turn the soldering iron back on. I am going to leave it at 360 degrees. This job. I count that ground plane does need quite a lot of heat. You're going to have to clean up that pin bag on it, stopping it from going through. Let's build some more in the hole, I think. Well, the hole's not quite big enough. So that's a bit cleaner. And it's slipped in quite nicely. Hey, that looks good. See what the insulation resistance tester tells us. Going straight to 1000 volts, which is 4 times the operating voltage that this will be experiencing, and twice the requirement for Australian regulations. And we have got 500 mega ohm at 1000 volts. And of course that one will be a dead short ground plane. So that's all a pass. Just going to switch this down to continuity. Turn the board over. Turn this on. So the meter will show a short. It's only running at 5 volts now. But from this terminal here up to, I think it's this one, we should have a circuit, which we do. So that's our active wire connection from there to there to show that we still have an active. And that's our neutral. And there is of course nothing between those two. Just to make sure, go back to the insulation resistance and measure between those two, and they're open. 500 megohm. So that board's now passed. The only other test I can do now is actually install it and make sure it works. That'll do for this video. If you like these kinds of videos, don't forget to click on like, subscribe, ring that notification bell. It's a form of support that helps the channel a great deal and costs you absolutely nothing. If you'd like to help the channel further, I do have a Patreon account, and there will be a link in the description, and you can join my long-term Patreons, VIPs, Go Lucky and Lorenz Berger, and my Builder Patreon, Al Morales 45. I do have a Discord channel as well, Discord server. There is a link in the description to that Discord server, and you can ask questions in there. And we'll see you in the next video.